Hi, in today's tutorial, we want to look at this Math Olympiad question, which from the first sight looks really intimidating, but we are going to reason through the solution. In every step of the way, we promise to bring clear explanation, so please watch the solution from the beginning to the end. Okay, let's start. We are given that 2 to the x plus 2 to the y plus 2 to the w is equal to 148. To solve for x, y, w, if we look at the left hand side, the expression here, each of them have the base 2. So one might be tempted to say, can we convert 148 to an index number whose base is 2? Okay, but unfortunately, it's not possible. 148 is not a power of 2. So what is the way forward? All right, so the way forward here that we want to present will be to convert this left-hand side to an expression which is the product. And then we'll also express the right-hand side to a similar expression which is a product. The only way out is to start with this one here, 2 to the power x, factorize it out. All right, so that we'll obtain a product. Our aim is to obtain a product, and then we'll look at that nature of that product. Then we'll see if we can also convert the right-hand side to have the same nature of the product that we obtain on the left-hand side. All right, factorize out 2 to the x. All right, if we do that, we'll have 2 to the x into, or we'll remove 2 to the x from here, we'll have 1. Then here it will be 2 to the y, all over 2 to the x. Here it will be 2 to the w, all over 2 to the x. All of that is equal to 148. Now, let's look at the expression that we obtain on the left-hand side. We say the nature of this expression will be what we're going to obtain on the right-hand side, what we'll also try to create on the right-hand side, following what we obtain on the right-hand side, on the left-hand side. Now, 2 raised to any power, 2 raised to any power is always even. Okay? If we take 2, raise it to any power, be it positive, be it negative, it will always be even. Any whole number power, of course, x, y, z are natural numbers. We're working here on natural numbers, please. So 2 raised to any natural number will always be even. All right? So this is even. But remember, if you take an even number, for example, 4, and you add 1 to it, we obtain an odd number. So any even number plus 1 will give us an odd number. 2 raised to the power y, all over 2 raised to the power x is even, plus an even expression. Even plus even will always give us even. But when the moment we add 1, the whole thing becomes odd. So this is an odd number, this is an even number. All right. So the nature of the left-hand side here is an even number multiplied to an odd number. Now, remember the base is 2. So our reasoning now will be to convert this 148 to a product wherein we have an even number multiplied to an odd number. And that even number preferably should be a number which is a power of 2. So let's look at it. 148 can be written as 1 multiplied to 148. Okay, that's good, but it's not good enough. What about 2? Yes, 2 multiplied to 74. All right, 2 again can go in there. That is 2 multiplied to 2 multiplied to 37. All right, which is 4 multiplied to 37. Okay, this one is better than this. This is an odd number multiplied to an even number. Yes, this one is better than this. So we'll preferably take this one. Even number multiplied to an odd number. The even number is also a power of 2. So we want to match things up. The even here is a power of 2. The even here is a power of 2. All right, so this one is the best choice that we'll take from this decomposition. Okay, so we're going to write 148 as 4 multiplied to 37. All right, so our expression now gives us as 2 to the x into 1 plus 2 to the y all over 2 to the x plus 2 to the w all over 2 to the x. All of that is equal to 4 times 37. All right, so we have this match. All right, so equating corresponding expressions, the even will go to the even. So we say 2 to the x will be equal to 4, but we know that 4 is the same as 2 squared. All right, so when we solve it out, it simply means that the value of x will be 2. Okay, so we've gotten the value of x. All right, corresponding expression for the odd, we equate them. So we have 1 plus 2 to the y all over 2 to the x plus 2 to the w all over 2 to the x is equal to 37. So we also equate now the odd expressions. The left hand odd expression and the right hand odd expression. Okay, now we know the value of x, so let's go ahead and put the value of x. We have 1 plus 2 to the y all over 2 squared plus 2 to the w all over 2 squared is equal to 37. 2 squared is 4. All right, we're going gradually. So we have 1 plus 2 to the y all over 4 plus 2 to the w all over 4 is equal to 37. Now, let's take this 1 from the left-hand side to the right-hand side. It simply means it will become subtraction there. So we're going to subtract there. So what we have here is 2 to the y all over 4 plus 2 to the w all over 4 will be equal to 37 minus 1. 37 minus 1 is 6. It's 36, sorry. So we'll just write 36 here. 36. All right. Now, if we multiply each expression by 4, we see we're going to do away with the denominators. So let's multiply all through by 4. We multiply all through by 4. We have 4 into 2 to the y all over 4. This one. We also multiply this one by 4. 4 into 2 to the w all over 4 is equal to, multiply this also by 4. 4 multiplied to 36. All right. Now you see the 4 cancels. So we end up with 2 to the y plus 2 to the w is equal to 4 times 36. This is the new expression we have. Okay. We have to look for the value of y and w. Now, if we look at the right-hand side, we have power of 4, power of 2 here, multiplied to 36, two even numbers. It's not an addition. Here we have addition. This is an even number, this is an even number. So, excuse me. If we now express this, if we go ahead and continue to express this as 4 times, there is 4 inside 36, okay, times 9. All right, our aim, we know that this one we can express it to this same nature where we have an even multiplied to an odd by simply factorizing out 2 to the y. We'll obtain an even multiplied to an odd. So let's go ahead and do this to have an even multiplied to an odd. So we can already see this is even, this is odd. So here we factorize out 2 to the y. It will be 2 to the y into 1 plus 2 to the w all over 2 to the y is equal to what we have there. Okay, so we obtain another match again. This is even from the same explanation I gave earlier, and this is odd. This is even here. 2 to the w all over 2 to the y is even, but when we add 1 it becomes odd. So we have even multiplied to odd. Here we have 4 times 4 is even, 9 is odd. So we also have even multiplied to odd. So we also have a situation where we can equate. Now let's go ahead and carry out similar equation and solve. So we are saying 2 to the y into 1 plus 2 to the w all over 2 to the y. All of that is equal to 4 is 2 squared times 2 squared times 9. This gives us 2 to the power 4. 2 to the power 4 times 9. Okay. Now, we have this expression equal to this expression. Even equals even. So we equate the even. 2 to the y equals 2 to the 4. We have this expression. The base is equal. The bases are equal, so it means we can equate the powers. So from here, we get the value of y. We have the value of y as 4. Okay. Now that we know the value of y, we will now go ahead and equate the odd part. 1 plus this expression, it must be equal to the odd this way. So we say 1 plus 2 to the w all over 2 to the y must be equal to 9. We know the value of y. We'll come and put it. That will give us 1 plus 2 to the w all over 2 to the power 4 must be equal to 9. All right, we'll take this one from the left hand side to the right hand side. It becomes subtraction. So we're saying 2 to the w all over 2 to the 4 will be 9 minus 1. 9 minus 1 is 8. So we'll have 2 to the w will be equal to 8. 2 to the w all over, here we'll have 2 to the w all over 2 to the 4 is equal to 8. Okay. Now we have 2 to the w all over 2 to the 4 is equal to 8. We know that 8 is also a number that can be expressed in index form with the base 2. 8 is simply 2 to the power 3. All right, so when we cross multiply, we're going to obtain 2 to the w will be equal to this one multiplied to that, 2 to the 4 multiplied to 2 to the 3. All right, so that's what we get there. All right, so from here, we have 2 to the w is equal to, the bases are equal, so we simply add their powers. 4 plus 3, that gives us 2 to the power 7. All right, so 2 to the w is equal to 2 to the power 7. This index expression equal to this index expression. The bases are equal, therefore means the powers are also equal. All right. So finally, we got the value of all our variables or all our unknowns. We got x to be 2. We got x to be 2. We got w to be 7. And we got y to be 4. All right. So we can always verify. If you want to verify to be sure if what you've gotten is correct, it's just suffice to put the values of x, y, w here on the left hand side to see if we obtain the right hand side. So if we want to verify our result, we just go ahead and put the value of x. The value of x is 2. The value of y, we found it to be 4. And the value of w, we found it to be 7. Now, do we have this result giving us 148? Do we have this result giving us 148? So we have 2 to the power 2 is 4. 2 to the power 4 is 16. 2 to the power 7 is 128. All right, 128. When we add this up, what do we get? This is 20 plus 128. It gives us 148, which is our right hand side. Okay, so we have shown that the values that we got for x, y, and w are the correct answers to our strange looking exponential equation.